Good morning, good evening, wherever you are. My name is Mark Borstein. I'm the CTO of Tremolo Security and the co-author of Kubernetes, an Enterprise Guide, second edition. So it's been a little while, and the last video we put out was for Chapter 8, where we talked about using GateKeeper. This chapter is Chapter 9, actually using GateKeeper to enforce node security. In the first edition of the book, if you read the first edition, this is where we covered pod security policies. Not long after, actually, it was while we were writing the first edition, come to think of it, pod security policies got deprecated, and we cover in the book why. But we decided to stick with pod security policies because at the time there was no replacement, at least an effective replacement. When Since then, and when we started writing the second edition of the book, the pod security standards that are now present, I believe, and on in default in 125, we're still in alpha. So we were kind of in this weird spot where we didn't want to keep talking about pod security policies because they're going away a lot sooner rather than later, and we didn't want to start focusing on the new pod security standards because they're still in alpha. There was a lot going to change. We didn't think that'd be really effective. So we decided to go with using GateKeeper for node policies and for node security. Now, I call it node security. I'm in the minority on this one because ultimately these policies are meant to protect your node from your containers. RBAC, excuse me, protects your API server from users, developers, identities, whatever, whereas node security is meant to protect your nodes, especially in a multi-tenant situation. So we'll get into that. So this chapter is broken into three pieces. The first piece talks about the way containers run on a node, tries to clear up some misconceptions. The second part, the first part also talks about how you're supposed to build your node. The second part, or excuse me, your container. The second part covers using GateKeeper to replace pod security policies and how what that looks like. And then the final part is how do you approach a multi-tenant system where you might need to have exceptions for different namespaces. How do you manage that? So I've got the chapter open here off screen, and where am I? Actually, the first thing I'm going to do, even before I get started, is we kind of broke one of our cardinal rules with this chapter where I always wanted you to be able to start the chapter fresh without having to use the previous chapter. So this one built on chapter 8, you had to have it up and running. So the first thing I'm going to do is I'm going to go into my Git repo, and I'm going to run this initialize for chapter. So this is going to deploy Open Unison. You don't actually need Open Unison for this chapter. It's just because it was a running container, we used it as an example. And then also set up GateKeeper, which we did in chapter 8. So this is going to run for a few minutes. Good time to grab a cup of coffee, and I'll see you in a few. Okay, great. So we now have our pods running. Of course, if I knew how to type. So we have our pods running there, and let's check GateKeeper. Beautiful. Okay, so GateKeeper's up and running. So let's start going through here. So the first thing we're going to do is we'll talk about node security and the differences between containers and virtual machines. Most people don't realize the fact that a container is not a virtual machine. So for instance, even though this is a Docker instance, and that Docker instance is running 2 containers, those individual containers are running their own containers. Well, if I go ahead and I look for Java, guess what? It's finding the pods that are running inside of those containers because those containers are ultimately running on the host VM. They're sharing processors, they're sharing memory, they're sharing disk. And so there really isn't a lot of isolation there. There's very little isolation, in fact. And we're going to get into an example of that here in a moment. So I'm just going to keep going. When folks manage to break out of a container, by break out, I mean, I have access to a container and I'm going to get out of that container and do something really bad. Sometimes a container breakout might mean that maybe I'm running an application, a web application with an old application stack. Somebody exploits that web application to get into the container. Once they're into the container, they can then start doing things they shouldn't be. Here's an example of a container breakout where we go ahead and grab a container that actually maps to the host file system. So this is Duffy Cooley came up with this, and I'm going to run this command. And what this is going to do is it's going to let me mount the root file system into my container. Good old copy and paste. That's how you know I'm not faking anything. There we go. So I'm now in a container. And in this container, I actually have access to the root file system. I have mounted the file system for my API or for my node, the node that this container is running on, into the container, which means now I have access to every single file, like, Etsy password, all the users that are running on there. So to show that this is the real thing, I'm now in root. I'm just going to touch a file. This is from a container. So I created this file. There it is. So I'm going to exit from my container. I'm going to enter my node. So here is my worker node. So I'm now on my worker node. Let's take a look at ls. Root. And there it is. This is from a container. So I was actually able to mount my root file system into my container and write to it. So now think about that for a second. I can add a user to my Etsy shadow or my Etsy password file if I want to give access to something. I can change file. I can do all sorts of things with access to the file system, not just reading files. If there are mounts, most people don't realize this, but when you do a volume mount inside of your container, all that's running is a mount command onto your node. And Kubernetes just maps everything so that you have access to it. Well, if I have access to the file system, I have access to all the mount points on that file system. So it really is an incredible amount of power that if you're not protecting your nodes, it's very easy to do. So that kind of gives you an idea as to what is in store. So in the next section, we talk about properly creating a container. We get into, don't use roots, minimize, only write to volumes, all good advice. So next we get into GateKeeper and what we're going to do about GateKeeper. We talk about why PSPs are going away, the really short version. They won't work well outside of Linux. They're basically designed around Linux, and we have Windows today, Windows containers. And two, they're really confusing, didn't really work well, and just were more trouble than they were worth. And we'll talk about some of those issues as we go through and we deploy our policies here. So the first thing we're going to do is we've got GateKeeper set up from the previous chapter. And the next thing we're going to do is we've got to get some node security policies going. So let's go ahead and clean out all of our old policies. Oops. You know, for now, we'll leave it like that. I'm still in the cluster. The node, there we go. So cleared those out. And so this clears out if you're running the, in the previous chapter, we were doing some experimenting with mutation. So this goes ahead and cleans that out. So now that we have our mutation engine back up and running, we've cleaned out from chapter 8. The next thing we want to do is set up some sane defaults. I personally am a huge fan of doing things with sane defaults. I'll be honest, it's one of the reasons why I always loved OpenShift is that it was secure by default. It had sane defaults. If you're deploying a microservice that doesn't need access to the host file system, you shouldn't have to explicitly say, stop access to the host file system. You should be able to write your YAML in such a way that is portable across different systems and is going to adapt accordingly to each system. So what we did was we took what we learned from chapter 8, where we set up initial defaults, and we said, all right, let's go ahead and set up some sane defaults for our environment. So things like dropping all capabilities by default, setting a default user context, making sure that you're running as a non-root user, making sure that you're not asking for privilege, things like that. So I'm going to go ahead and we took these mutations and we created a single YAML file for you. And you can see here, chapter 9 default mutations. Here we go. So here's an example of a default mutation where we said, let's make sure that we are not allowing privilege escalation. So if there's in the privilege escalation section, if it doesn't exist, assign it. Another example here is, so this is in a init containers. Another one is, for instance, FS group. If you don't specify a file system group, set one for 3000. So this way, even if your pod or your container, when you set it up, says run as 0, run as root, by default, it's going to run as 3000. You're not relying on the container developer or even the application developer to design a YAML to run this container securely, or at least with some sane defaults. Make them say, no, I want to have escalated privilege instead of the default, which is you can do whatever you want. So let's go ahead and apply those. So those have all been applied. And the next thing we're going to do is see how these defaults get applied. So the thing with GateKeeper is, and this is true of any admission controller based system, which Kubernetes is all of them, nothing gets applied to pods until the pod gets created. So even though we've applied these policies for default mutations, they're not actually going to be assigned to a pod until you go ahead and delete the pod and let it be recreated. So here's an example. I'm going to skip here a little bit. So here we're going to take a look at our security context in OpenUnison for our OpenUnison operator. Again, it's just a pod. And we'll see nothing comes back because we don't have a security context. We don't ship one by default. We don't want to, as a vendor, we don't want to be in a situation where our defaults conflict with your vendor's implementation for Kubernetes. So we say, okay, we're going to leave that as an exercise to the reader. So let's go ahead and now delete all of our pods except for what's in GateKeeper. Because if we delete the GateKeeper pods, then well, there'd be nothing to actually apply the defaults. So give this a couple of minutes for everything to delete, and we'll be back. Okay, great. So our pods have been deleted, and let's check the same thing. So we're going to look at the Open Unison operator, see what security context says. Before deleting the pods, it had no context, and now it does. So our default contexts are there. We've dropped all capabilities. We don't allow privilege escalation. Um, and we're running as specific groups. Now, that said, this is not enforcement. So if I specifically said in my pod spec, hey, I'm going to set allow privilege escalation to true, that would still be true here. This is not an enforcement mechanism. These are sane defaults. So now any YAML that comes in, any pod specification that comes in is now covered, or at least has our default policies. So that said, we need to make sure that we only want people to do allowed privileged on pods where it matters. And so the next step is to go ahead and create constraints. Now, the Open Policy Agent project has done a great job of building example constraints based on pod security policies. So we've already deployed the constraint templates. Now it's time to actually apply those constraints. Get this from the book. Oh, I missed a step here. Oh, I actually have to deploy the policy constraint templates. No. Where did I miss? Oh, here we go. I missed this one. So this will deploy our templates. Now we'll deploy our constraints. Almost. There we go. Okay, so we're waiting for GateKeeper to process all of the templates we had created, create the appropriate CRDs, and now that those CRDs are all deployed, we're able to actually deploy the minimum constraints. So everything is running in audit mode. We're not actually blocking anything at the moment. And so the way that you actually figure out whether or not something is working is the audit system inside of GateKeeper will compare your existing configuration to the constraints and add it to the status object. This gets really difficult to try and look at manually as a human being because you have to read everything. So we put together this nice little script that goes through the status objects of all of our constraint policies just to give us an idea of what's broken. So we'll see here that the allowed users policy is being violated. That's all inside of GateKeeper, so we're going to ignore that. But we have issues with allowed privilege escalation. We have 2 containers, and we have capabilities. And then finally, we have networking ports. So let's figure out what's broken. So we're going to go and get the details. So what this command is going to do is it's going to get the object that we create, our actual constraint. We're going to get all of the status, all of the violations, and we're going to make it a nice, pretty print, make it a little easier for us to read. So we have 2 violations on allow privilege escalation constraint template implementation. One for our Nginx ingress controller, which makes sense. Nginx ingress, for some reason, wants to be able to run on port 80 and 443, which needs some special privileges. And the local path provisioner, which makes sense because it's creating objects on your file system. Let's go ahead and take a look at the other one that's broken, is capabilities. So I'm actually on page 298 if you're following along in the book. Of course, good old copy and paste strikes again. So that goes there. There we go. Almost. Oh, right. Um, I'm getting the pod from the violation. So let's do that. So let's take a look at the violation. Let's take a look at the security context. So this is why I was talking about this netbind service. That capability is what allows a process to request a privileged port. So anything under 1024 is privileged in Unix land. Port 80 and port 443 are privileged. So you need to ask to be able to bind to those. Once upon a time, you had to be root. This is a capability that lets you run as non-root to do that. But that violates our constraint, which says you can't request any special capabilities. So that's what's triggering that violation. And then this does as well for privilege escalation. So let's go ahead and make this work. We're going to take the quick and dirty approach, where we are going to just say that we're not going to apply these particular policies to the ingress nginx and the local path provisioner namespaces. This is a big area of difference between pod security policies and using GateKeeper is pod security policies tried to find the best policy to apply based on who was creating the pod and who the pod was running as, whereas GateKeeper just tries to find the first one that finds all of them that matches. So if a policy matches, it's going to apply it. Doesn't matter who the pod's running as. So what you need to do is say, okay, well, if I don't want this blanket policy to apply, I need to exclude it from the blanket policy. So that's what we do here. So I'm on page 300. Whoops. So let's go ahead and apply the let's make it work policy. Now, if we run our shell again, or our audit check, nothing's actually changed. This is still 2, that's still 2, that's still 1. It takes a minute or two for the policy engine to audit everything when things are new. So we're going to sit for a minute, and when we come back, we're going to see that the policy is applied and we are no longer waiting, or that we're no longer in violation. All right, so gatekeepers applied the policies and re-audited the cluster. So this was before those all policies got applied. You'll see we had a couple of violations here, a couple of violations here, and a couple of violations here. Removing ingress nginx and local path provisioner from those policies now gives us a clean bill of health. So we're no longer in policy violation land, except for those 12 gatekeeper policies, because that's all inside the gatekeeper namespace. So we can avoid those. The next question though is, okay, we're not violating the blanket policies, but you still want to apply policies to ingress nginx, especially ingress nginx, because that is literally the entranceway that all your applications have to your cluster. So you want to make sure that's locked down pretty solid and saying, well, we're going to let it ask for all capabilities, even though we just want to stop this one capability isn't a great idea. So now we're going to apply more specific policies directly to ingress nginx to make sure that ingress nginx is going to run only with the capabilities it needs to be able to run on port 80 and 443. So we go ahead and we do that in here, chapter 9. Chapter 9. Let's see here, which one is it? So one of these YAML files. This one? Nope. Nope. That was the one that made it work. No. enforce node policy. Oh, maybe I didn't actually end up creating it. Okay, no big deal. So let's go ahead and grab this. Enforce nginx.yaml. And of course, because kinds, that goes there, namespaces goes with match because YAML. No, namespaces goes here. Kinds, parameters lined up with match. So going back to chapter 8 where we set up implementations of our constraint policies, the template is the Kate's PSP capabilities template. We're going to say allow ingress nginx to any pod running in the ingress nginx namespace. It's still going to have required drop capabilities all. So the way that drop capabilities work is you don't just request the ones you want, you drop the ones you don't want. So ingress nginx says, nope, we're going to drop all of them and not specific ones. And then here are the allowed capabilities. So we're first going to drop them, and this is the one capability we're allowed. So if a pod in ingress nginx doesn't have required drop capabilities all, it'll fail this template implementation. If it requests a capability other than netbind services, it's going to fail. So let's go ahead and write it. Oops. Oops, I don't have aliases on here. All right, so that's been created, and now we have locked down our policies. So we've gone through and debugged, what are our sane defaults, what happens when we apply a good set of default policies, and then going through and figuring out what's broken. So in the final section, we talk about multi-tenancy and how to create a multi-tenant cluster. In chapter 6, we talked about multi-tenancy with RBAC. Here we're talking specifically about multi-tenancy with node security, which makes a lot of sense because, if I've got two tenants, they might be running on the same physical node. You don't want their workloads to be able to interact with each other. Now, depending on how you have it set up, you might want to have some kind of physical enforcement by saying this tenant has these nodes, those tenants have those nodes. There are different ways you can enforce that with labeling. But if you have multiple workloads running on the same system, you want to be able to isolate them. So we talk about how you can't really have like a blanket policy the way you could with PSP and then provide more specific policies. GateKeeper is not that layered approach. You have to know exactly what you're applying to. So we talk about how to do that in the book. Lots of pretty pictures. So first, then we go ahead and we set up life in a multi-tenant cluster. So first we're going to go ahead and clear out all our own policies. So all of our old policies are now deleted. And let's go ahead and create our multi-tenant policies. Got my scratch pad over here. So those have been created. We'll give them a second to run. Let's take a look here at YAML, minimal GateKeeper constraints. So this is very similar to our previous set. It's just built specifically for a multi-tenant cluster. So we explicitly named a lot of namespaces that we didn't want to apply these to because these are more system namespaces. And I also got lazy and didn't want to go crazy, building a commercial cluster from scratch. Point is now is that we now have these policies applying to all namespace or to um, these policies that can be applied to all namespaces. Um, so we have our namespaces in place. The next thing that we're going to want to do is make sure that each template has an implementation in a namespace before we allow a pod to get created. Because in a multi-tenant solution, you now have to say, okay, the policy needs to be applied directly to a namespace. You have to name that namespace. And so you want to make sure in that situation that you have policies in place applying to that namespace before you let anybody launch a pod. Because right now, if I create a new namespace, I can run anything in it that I want because we're explicitly applying our global policies to specific namespaces, system level namespaces. So what we're going to want to do is write a policy that says, make sure you have policies in place. So if we take a look here, OPA, so here is our example where we're saying, you know what, let's make sure that there's a privilege escalation policy in place. Now, that privilege escalation policy might say you can do privileged escalation, but the policy has to exist. Otherwise, you can't create any pods. So let's go ahead and apply this configuration. So that goes ahead and create. Now that the other thing that we actually just did was make sure that GateKeeper is now enforcing, which we weren't doing before. All right, so we have created our policies that says you have to have policies for each namespace. So let's go ahead and show you what happens now that we have this enforced. Clear this so you can see better. So first thing we're going to do is create a new namespace. Next thing we're going to do is we're going to run a pod that does a hello world. Now, because we've created a new namespace that has no policies in place, this is going to fail. See, we don't have any namespace policies in place. So GateKeeper is going to fail the ability to run this pod. So the next thing we're going to do is create policies for our namespace. So we create our policies in the namespace. Take a look real quickly here. Multi-tenant, YAML, check new pods. So these are our new node security policies. And really, it's not that crazy. It's just making sure that we have deny all in our namespace, our pod namespace. We're making sure that we're dropping all. So these are namespace level objects. So as a namespace owner in a multi-tenant system, I can't create these. The system owner needs to create these for me, hopefully. I guess it depends on the way you set up RBAC. But you generally don't want your tenants to be able to create their own policies. So you want to control that at the namespace level. But what this now does is this tells GateKeeper, hey, we've locked down this namespace, our policies are in place. Let's go ahead and try running that group control create command again. And this time it's going to work because we didn't violate any of our constraints, and those constraints actually existed. So that brings us to the end of the chapter. This is a fun one because you're really diving into some of the best misconceptions about the way security works in Kubernetes. Um, Had a lot of fun building this one. We did go through, if you've tried this before now, I really cleaned up a lot of the scripts. Some of the scripts didn't age particularly well as versions have changed, so I made sure they all lined up. Um, but if you've enjoyed it, a link to buy the book, if you haven't already, is available in the notes up on Amazon. And please smash that like and subscribe button. It really does make a difference. Have a great day, and thank you for joining us.